All right, Calc BC, Unit 3, Day 11, office hours. Some more free response problems. Hopefully you've tried them. And let's take a look at them. So some are calculator, some are no calculator. So this is a graphing calculator problem. And they're giving you the velocity in the x and y direction, right? dy dt, dx dt. They're telling you times greater than 0. This is at time 2. This is the position. So they're giving you the initial condition that we're probably going to use at some point. Hopefully we can use our calculator to do a lot of the hard work on this problem. All right. So let's see. Find the acceleration vector and speed. That's a pretty straightforward question. Point breakdown is 2, 2, 2, 3 for a total of 9. Acceleration vector and speed of the object. So we already have the velocity. So acceleration, say in the x direction at time 2 is going to equal the derivative of velocity at time 2. So we could just use your calculator to do that. I'm probably going to go enter these equations in my y menu because it probably saved me some time. Inverse sine 1 minus 2 e to the negative t, but I'm putting x's in. I'm not just regular function mode. Parentheses for x divided by parentheses 1 plus x to the third. So that looks good. Go back to the screen. And so, and I'm going to do acceleration in the y direction also this way. Now, of course, you could do a bunch of work and find the derivatives yourself. That does not sound like, I don't know, doesn't sound good. So math 8, bars, y bars, function y1, comma x, comma 2. There's that one. Do the same thing, but do vars, y vars, function y2. There's that one. So 0.395623, negative 0.740740. So the acceleration at time 2, vector, it says vector, that's usually what we do, x and y components, kind of like ordered pair. So 0.395 comma negative 0.740. Truncated, you could do 0.396, negative 0.741 if you wanted. Now, that's 1 point. That's not enough work to deserve 2 points. And the speed. I see people just like missing that. Oh, there's another thing we got to do. So speed at time 2 is going to be the square root of the velocity in the x direction at time 2 plus the velocity in the y direction at time 2 squared. So we could, I guess, look up what those values are. We could plug them all in. I mean, we could say inverse sine of 1 minus 2e to the negative 2 squared plus 4 times 2 is 8 over 9 squared, square root, parentheses, inverse sine of 1 minus 2e to the negative 2, close, close, close squared plus 8/9 squared is 1.207 or 1.208. That's a point. All right. Part B. The curve has a vertical tangent line at 1 point. At what time t is the object at this point? So we're looking for a vertical tangent, which in general on any kind of graph is when the slope is infinitely steep. So it's undefined caused by division by 0. but we also know that dy dx is dy dt over dx dt. So it's really dx dt that equals 0 that we're concerned with. So we have that function. I don't think you really want to try and solve that. You're welcome to if you want. I mean, I could show the work for that, but you could just use your calculator and graph it. Now that's so we go to y equals. I'm going to turn the second one off. Got a window. I'm looking for an answer sometime 0. We can say 0 to 10 to start off with. Look for the x-intercept. So right there. So t equals 0, 0 to 1, 0.75 maybe, 0.693. I mean, if you want to do work, you say, well, this is asking, what angle do you take of to get 0? Well, you can say, well, probably 0. Or other answers, it's actually 0 plus pi k. But we could try 0 for the first one. I mean, this is if you don't want to use your calculator to help you. So this should be the same answer. Let's try it out. Natural log of 0.5. Oh, that one came out negative. Oh, wait, hold on. No, this should be 2. I made a mistake. If it really did come out negative, then you might just have to try one of the other plus pi or subtract pi and see when you get a positive one. Okay, so that's it for that problem. Part C says, let M denote the slope of the line tangent to the curve. Okay, write expression for M in terms of t and use it to evaluate the limit. So we're talking about the slope, which is the same as dy dx, which is dy dt over dx dt. And you have all this stuff. So mt equals 4t over 1 plus t cubed over inverse sine of 1 minus 2e to the negative t. I mean, that's it. I mean, we could write it a little nicer, I guess. A little bit nicer. This isn't necessary for these points. You might end up, maybe it'll be helpful for some of the work you're doing. But that's a point. And then we're going to take the limit as t goes to infinity, it says, of mt. So I'll go, I don't know, we could just use the original one. Now, I think it would be helpful, at least for this, to think of this as 2 over e to the t. So as t goes to infinity, these are the denominator terms here, but that's going to go to 0, and this is going to be inverse sine of 1. And you say, well, when does sine equal 1? Principal values, it's going to be pi over 2. It's still going to be 0, right? I mean, even if you did it with this one, it's going to be 0. So there you go. D says the graph of the curve has a horizontal asymptote. Horizontal asymptote. So that's in behavior. Y equals C. Write but do not evaluate expression involving an improper integral. that represents this value c. Improper integral. Okay. So horizontal asymptote would be when the limit when t goes to infinity plus or minus. It says graph the curve as a horizontal asymptote. And that would be when the slope goes to 0. The slope should go to 0. T goes to infinity. Okay. So if we do it for x, which, let's see, we don't have an expression for. I mean, I think we just confirmed that the slope is 0. This is a little trickier. So how do we find what that y value is? Well, we could integrate y prime and get y, right? And we say, well, we go from the known point 2 to infinity, and then you would get this. All right, and this is what we want to know. What's the y values that go to infinity? Because that would be the horizontal asymptote. And then this is y2, I think they gave us was -3, right? So, and this is going to be the c value. So c equals, it's going to be +3. It's going to be -3 plus the integral of 2 to infinity of 4t over 1 plus t cubed dt. So that was kind of weird, tricky. 1 point for the limits, 1 point for the integrand, 1 point for the initial value, and there we go. That was kind of weird. Yeah, I mean, it's really, we're trying to figure out what the limit of y is as t goes infinity. I think it helps that because x goes to infinity. Okay. All right. Kind of weird. Next question is graphing calculator. I'm just going to go ahead and enter these in right now. So I think I'll need them. It'll help. Tangent e to negative. I'm putting x's in. I'm not in parametric mode. I don't think I ever will. Secant is 1 over cosine. Right? So that's the way I'm going to type it in. 1 over cosine. Okay. So that's good. Time is greater than 0, which is common. Time 1, position. So this is your x and your y. So x1 equals 2, y1 equals -3. Initial condition. Okay, part A says write an equation for the tangent line at 2, -3. Now what you need to realize is that corresponds to time 1. So the slope is going to be dy dx, which is going to be dy dt over dx dt at time 1. So we have those. So that's going to be secant of e to the -1 over tangent of e to the -1. Now we could type this in our calculator and get decimal. I mean, we could try and clean it up also, but that's up to you. I mean, if you want to clean it up, this is 1 over cosine, right? And this is sine over cosine. So this cleans up pretty nice to 1 over sine e to the -1. Or you could just type in the original one. So I mean, we could do 1 divided by sine of e to the -1, 2.780577. Or you could do it all. I mean, I think you have to do parentheses 1 over cosine e to the negative 1, close, divided by tangent of e to the negative 1, same answer. Okay. Okay, so we're going to write the equation line. Y plus 3 equals 2.780 x minus 2. Point breakdown here is 2, 2, 2, 3. So you got 1 point for getting your slope and 1 point for your equation, which I would just leave in pencil form. B says find the acceleration vector and speed. It's a lot like last one. So acceleration vector, ax at time 1 is just going to be the derivative of velocity at time 1. So I'll do that in my calculator, and then the acceleration time 1 is going to be the acceleration of velocity derivative. So I can do that in my calculator, math 8, vars, y vars function, y1, comma x, comma 1. And I'm going to do it again. Vars, y vars function, y2. Those are my two answers. So negative 0.422529, negative 0.151957. And so the acceleration at time 1 is as a vector, negative 0.422, comma, negative 0.151, or you could round it if you want. So that's 1 point. And then we got to do speed. So speed at time 1 is going to be the square root of the velocity at time 1 squared plus the velocity in the x direction, the velocity in the y direction at time 1. So, we could write this out if we want. This would be a tangent of e to the negative 1 squared plus secant e to the negative 1 squared. So let's see, square root of parentheses tangent e to the negative 1, close, squared plus 1 divided by cosine e to the negative 1, close, squared, close. 1.138 or 1.139. It's up to you. That's one more point. Okay. C, find the total distance traveled. Okay, that's a common question. So total distance traveled, that's that equation where it's the integral speed, right? Just like it was last year with 1 dimensions, but speed is now, it says total distance 1 to 2 of tangent e to the negative 1, or negative t, sorry, squared plus secant e to the negative t squared dt. So show the setup. That's worth at least a point. That's a point. And then we're going to get the answer on our calculator. So hopefully, I think the easiest way to do this is math 9, and then do square root vars, y vars function y1 squared plus vars, y vars function y2 squared, close, comma x, comma 1, comma 2. I don't think you want to try and figure that out by hand. 1.059. So there you go. It's total distance. D, so far it's been really smooth. We've gotten 6 points pretty easily. That's enough for a 5 in general if you average that. So we have 3 points. Maybe something weird here. Is there a time t greater than 0 where the object is on the y-axis? Explain why or why not. So this one's kind of weird. On the y-axis means that x equals 0, right? I don't know if if we could solve this, we're not going to integrate these by hand because so we got to use our calculator. Maybe fundamental thermocalculus part 1. So we could say, well, we could say if you integrate x prime, and we know that at time 1, we know it, and then we could go to, I don't know, like, I don't know. I mean, 1 to some time or something? Can we do this? Would this work? This is 2, but I don't think we can. This would require us being able to integrate this by hand. You know what I mean? Can you integrate? Can you find the antiderivative of this without a calculator? No. So that's the first thing I think of. If we do that, then we could find the answer. But it's a little more complicated than that. So here's the deal: we know the position at time 1. Let's start at time. Let's find the position at time 0. So let's say, okay, well, 0 to 1 of x prime t dt equals x1 minus x0. Now we can do definite integrals on our calculator. So one of the problems on this one was it had a variable in it. So x1 is 2, so x0 equals 2 minus 0 to 1 of tangent e to the negative t dt. So we could use our calculator to find that. 2 minus math 9 vars y vars function y1 comma x comma 0 comma 1. So this is the position at the beginning at time 0. That's the x coordinate. It's really the x value that we're concerned with. We really don't care about the y values. The y-axis is x equals 0. Now, so we have the x coordinate. So the particle starts at the right side of the y-axis, right? It starts at the right side. And then I guess what we could do is we could look at the velocity. Now the velocity, Vx equals, dx dt x prime t was tangent of e to the negative t. Now, what happens for all times for t greater than or equals 0 is it consistently positive? It'd be kind of like a line, doing a line check. And here's the deal: as you plug bigger and bigger numbers in here, and it's only positive numbers, this is going to keep getting smaller and smaller and smaller. So you're going to keep approaching. At 0, it's going to be tangent of 1. And the tangent curve looks like this. That's pi over 2, negative pi over 2. So we're starting at 1, which is definitely like here. And we're going this way and this way and this way. We're going closer and closer to 0. That's the derivative. So the derivative starts off positive, and then it's positive all the time. It doesn't even matter what the size is, but the derivative is always positive. So this is always greater than 0. So that means it's always moving to the right, no matter what. It's always moving to the right. And so there's no way it could ever be on the y-axis. So we could say like the particle starts to the right of the y-axis, and since x prime t is greater than 0 for all t greater than or equals 0, the object is always moving to the right and therefore is never on the y-axis. So I don't know. So that was weird. That one's kind of a tough one. So, but hey, you got your first 6 points, hopefully. Okay. All right. Next one is a graphic character problem. Also, so they're giving you velocity vectors. They're giving you position times 0. And then they tell you part of the position at time 2. So x0 equals negative 13, y0 equals 5, and then x2 is 3, but they don't give you y2. All right. So A, find the acceleration vector and speed. I mean, this question should be super easy by now, right? Because acceleration in the x direction at time 2 is going to be the derivative of the velocity in the x direction at time 2. And acceleration in the y direction at time 2 is going to be the derivative of the y velocity at time 2. And our calculator can do that really easily, quickly for us. So I'm going to go in here and type these equations. 12x minus 3x squared, natural log, parentheses, 1 plus parentheses, x minus 4, close, raised to the 4th, close. Okay. And now on my home screen, I'm going to do math 8, vars y, vars function y1, comma x, comma 2. That's one answer. I'm going to do the same thing. Change it to vars y, vars function y2. There you go. You have everything you need. So this is 0, and this is negative 1.882352. So the acceleration at time 2 is 0. We usually write it like this. 0, comma, negative 1.882. Now it's probably only a point. Point breakdown is 2, 3, 2, 2 this time. Okay, the speed at time 2 is going to be the interval of the velocity at time 2 squared. So velocity of y squared. That's it. And we could put these in. Velocity x, that's going to be 24. 24 minus 12 is 12 squared. And the other one's going to be natural log of, that's going to be 2, negative 2 to the 4th. It's positive 16, 17 squared. So square root of 144 plus parentheses natural log of 17, close, close, squared, close. 12.329 or 12.330. That's a point. Acceleration vectors, speed, which should be easy now. Okay. B says find the y coordinate of P. Now P is that time, is that point at time 2. So what they're asking for is they're asking for y2. Okay. So fundamental theorem of calculus part 1. Use it all the time. We're going to integrate y prime to get y. And we're going to use the known point at 0, known point at time 0, and use it to find time 2. So I just always start with that. So that means that y2, y0 was 5. So y2 is going to be 5 plus 0 to 2 of natural log of 1 plus t minus 4 to the fourth dt. So that's my setup, which is probably worth a couple points. And then I'm going to do 5 plus math 9 vars y vars function y2 comma x comma 0 comma 2. The answer is 13.671. Okay, 3 points. It's not. That should be a very straightforward kind of problem. So 1 point for the answer, 1 point for the initial condition, 1 point for the integral. Okay, C. Write equation tangent line. Tangent line at P. Well, we already have the coordinates. Right? The coordinates are 3, 13.671. We need the slope. Now we also need to realize this is at time 2, they said. So we need the slope, which is dy dx at time 2. Do we find this ever? No. Okay. Which is going to be dy dt over dx dt at time 2, which is going to be, I mean, we could write it. We could say natural log. When we plug, natural log of 17 over 12. All right. We already calculated that when we did the speed up there. Or you can use your calculator to do it again or whatever. Natural log of 17 divided by 12, 0.236101. So you get a point for getting your slope, and then you write the equation y minus 13.671 equals 0.236 x minus 3. And that's point slope form. Leave it. Okay, D says, well, for what value t, if any, is the object at rest? Explain your reasoning. Now, object at rest, I think it means that it can't be moving in either direction, right? I think this is what we're looking for. So let's go and solve these. Dx dt, 12t minus 3t squared equals 0. You can use your calculator to solve this, but this is pretty easy to solve by hand. Right? So that's when it's not moving in the x direction, but we also have to separately do this one. And we could exponentiate both sides. You can use your calculator to do this, but this one turns out pretty nice. So we have a time show up in both of them. So I guess that's where it's at rest. So we're going to write the object is at rest at time t equals 4, since the velocity is 0 in both the x and y directions. One point for your answer and your reasoning. 1 point for finding t equals 4. All right. Okay, one more to go. All right. Now, This one's not so much a free response problem. This one's more just, I don't know, kind of, I guess, but a little different. No calculator. So given the positions, we're going to find the velocity vector. I mean, that could be a common question. So the velocity vector, the velocity in the x direction at pi, the velocity in the x direction in general is going to be x prime t, which is going to be 1 plus sine t. And so then velocity x at pi is going to be 1 plus sine pi, and sine pi is 0, so it's going to be 1. Velocity in the y direction is going to be the derivative of the y position, which is going to be cosine. So we'll plug pi into that, and we'll get 1, negative 1. So I'm going to write it like this as a vector, 1 comma negative 1. Okay. B, when is Albert flying horizontally? So when you're moving horizontally, that means that your tangent line slope is 0, but more specifically, dy dt equals 0. There's no movement in the y direction. We have dy dt. In the last problem we found it was cosine t. So that's going to be t is going to equal 0 at pi over 2 plus pi k. So pi over 2, 3 pi over 2. Now it's 0 to 10, so that's like 9. That's like 4.5. 5 pi over 2 would be like 7. That'd be like 15 over 2, 7. 7 pi over 2 is going to be like, that's going to be over 10. So these are the times where it happens. As long as dx dt doesn't equal 0 at the same places. So we're going to essentially find that on the next problem anyway. So vertical is when the slope is undefined because it's infinitely steep. It's going to be when dx dt equals 0, which is 1 plus sine of t. So sine t equals negative 1. So t equals negative 1 at 3 pi over 2 plus 2 pi k. And so 3 pi over 2. And the next one would be 7 pi over 2. That's too big. So we have that. Now here's the deal. It can't be vertical and horizontal at the same time. Well, it's not. It's an indeterminate form. So what we should do is do dy dx equals 0 over 0 at 3 pi over 2. So we need to take the limit as t approaches 3 pi over 2. We'll do the derivative. So we would need to do L'Hopital's rule. So we do the derivative at the top, which was dy dt. So that'd be negative sine, and the derivative at the bottom, dx dt, would give you cosine. And so now when we plug 3 pi over 2 into this, that's going to be positive 1 over 0. So it is going to be undefined. Therefore, it is vertical. It is not horizontal. We confirmed it. If it shows up on both these, then you got to watch out. You got to do L'Hopital's rule. And L'Hopital's rule tells us it is indeed undefined. Because at first you get 0 for 0. So you got to watch out for that. So I took that answer off of C. D, speed, pi over 2 is going to be the square root of Vx pi over 2 squared, Vy pi over 2 squared. And do we calculate this already? Well, good. So that's going to be 1 plus sine of pi over 2 squared and cosine of pi over 2 squared. Sine pi over 2 is 1. Cosine pi over 2 is 0. So this is going to be the square root of 4, which is going to be 2. There you go. Lots of good practice. Hopefully you're getting to the point where you feel like, yeah, I can do these. Done a lot of them. So